Hey, John Gilroy here. The White House wants to promote safe and secure AI. DHS wants to promote AI safety and security. Today, a focus on secure AI for the federal government. Hit the music, Manny.
Welcome to the Federal Tech Podcast, where industry leaders share insights on innovation with a focus on reducing cost and improving security for federal technology. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.
Welcome to the Federal Tech Podcast, a podcast that connects you to federal technology leaders. My name is John Gilroy, and I will be your moderator. Our guest today is Dr. Ellison Anne Williams, founder and CEO of a company called Enveil, Enveil. Well, Ellison, you don't have to be Sherlock Holmes to figure out the federal government recognizes the risk in leveraging artificial intelligence to solve federal data problems. I mean, just open up your eyes. Executive Order 2021 on improving the nation's cybersecurity. NIST followed up with a AI Safety and Risk Consortium. The folks over at DHS assembled the AI Safety and Security Advisory Board. I'm sure I can go through my list all day long. So Ellison, what's the big deal? Why all of a sudden interest in secure AI? Let's just get dazzled by the shiny thing, huh?
Yes. Well, first, John, thank you so much for having me. Really appreciate it. And as you pointed out, yes, secure AI is having a moment, but it is well deserved. So I think the reason you see so much focus on that right now is, of course, there's increased focus with the adoption of AI. Certainly the hype is off the charts, but there is a lot of basis for that hype, for that attention in terms of what AI can deliver, AI machine learning, as we would say, could deliver in terms of kind of automated insights, greater efficiencies, all kinds of things. And if you're going to adopt it and adopt it broadly, then you've got to make sure that you're doing that in a safe, trustworthy, responsible, and secure fashion. And that's really, really the case for our different kind of federal entities and organizations that deal with very, very sensitive types of data and situations on a daily basis. So you see quite a focus on security as it relates to the adoption of AI globally, but in particular in the federal ecosystem.
So let's go back to grade 3, and you're the little teacher in grade 3. And so, well, what exactly is secure AI from your perspective? How would you define it for our listeners?
So secure AI is the process of, to me, securing the entire AI or machine learning workflow end to end, all the way from taking a look at what does the application security look like for AI or machine learning workflows, down to the data itself, the data that it's built on, from the perspective of training models, which are the unit of work in AI or machine learning, to deploying those models, et cetera. That's all based on data. Only as good as the data over which you train and use these kind of AI and machine learning workflows. So it's very, very comprehensive to take a look at what does it mean to secure AI, but it really comes down to securing the workflows end to end at all points and in all dimensions.
Yeah, that little funny word you used, all. Now, if I work for Gilroy Donuts, all the machines have to be locked down. But the federal government, when we say all, just look at the DOD. I mean, all means everywhere. I mean, it's one thing to say, sweep the floor at Joe's Donuts, but another thing to how do you control all the different data points all over the world? I mean, this has got to be almost impossible to do.
Well, the good news is that a lot of the components of AI security are things that organizations should already be doing, already have in place. So when you look about AI security, and you take a look at workflows there, it's really driven by applications in the environment and in the ecosystem. So things that you do today to secure applications in the ecosystem, things that you do today for authentication and access control, et cetera, for security, just carry over and apply from an AI perspective. So that's the good news, that there is a lot that is translatable between your normal kind of application or analytic workflows and AI or machine learning workflows. The new parts that you have to pay attention to in AI from a security standpoint relate to the models themselves. So remember, I mentioned just briefly a second ago that the unit of work in an AI or machine learning workflow is a model, is a machine learning model. And so there are various new aspects of model security that have to be considered when you start looking at secure AI. And those are the things that organizations today are trying to get their head around of how they're going to deal with it, et cetera. And the good news there, I will say, is that there are technologies, and we'll get to this a little bit, that can deal directly with providing model-centric security, namely a family of technologies called privacy-enhancing technologies, or PETs.
And there's new models being released every day. And I think that's the challenge, is like, oh, yeah, well, that was there's new ones, and this is the best and the brightest and everything else. So it's even hard to keep track of these models, isn't it?
Oh, for sure. Absolutely. And of course, models are only as good as the data you're training over. As you have more data, you want to retrain your model so it can give you better insights, et cetera. So this cycle will always continue in terms of making your models better, developing new models, et cetera. So you have to be mindful of that from a security standpoint. But as we saw back in October of last year, when we had a huge push for AI adoption as a result of generative AI, ChatGPT, et cetera, we also had a similar push for, wait a second, if we're going to adopt it throughout the organization, as we talked about before, then we have to make sure that we do that in a safe, trustworthy, responsible way, which also includes in a secure manner. So some of the kind of market framing momentum that we saw coming out of that was the White House last October put out their AI executive order for safe, trustworthy, responsible AI. And then, of course, that was echoed globally very shortly thereafter out in the UK with their NCSC guidelines for secure AI development. And that was coordinated with a number of bodies globally. Now, the interesting thing in that executive order and all this kind of global framing documents around AI security, or how do you do this in that safe, trustworthy, responsible way, was an acknowledgement of new types of considerations that have to be addressed in AI machine learning workflows, really getting to model-centric security. And those kinds of considerations are uniquely addressed by the family of technologies called privacy-enhancing technologies. And we can talk about why model-centric security is a thing. What makes it different?
I think that's the point. I mean, I was on LinkedIn this morning, and there's a news item came up. Anthropic just released a new model. I mean, it seems to be all around us now. And there's some discussions we're going to have today in the next few weeks that we couldn't have had 4 or 5 years ago, especially with security concerns. I mean, anyone who's in this business are learning words like jailbreak and like prompt injection attack. Now, we all remember SQL injection, so it seems like the malicious actors are taking an old tool and applying it to the new world. So there's so many things going on out there. I think you have to, what you're saying was maybe one solution might be with this thing called privacy-enhancing technologies that can control all the change we have. Is that right?
Yeah, there are a couple of risks that privacy-enhancing technologies uniquely address, but they're inherent to models in and of themselves. So remember, we talked about models being the unit of work for machine learning. So the really interesting thing with models is that the machine learning models encode the data that they were trained over. So clearly, if that training data has any sensitivity to it whatsoever, then the models similarly have the same sensitivity. So you could phrase it in terms of whatever classification that data has that you train the model over, the model is also going to be classified in the same way. And so what happens is, in practice, organizations will not use models that have been trained over sensitive data outside of the walls of the original training data location, which means you're greatly hampering the use of those machine learning models, the sensitive machine learning models used across different kinds of silos of data, boundaries of data between different organizations, out in third-party data environments, et cetera. And this is true not only in the federal space, in the audience that we're talking to, but it's similarly true. We see this exactly mirrored in the commercial ecosystem, where sensitivity takes slightly different forms in terms of personal information or proprietary information for company, et cetera. But the principle holds true, and that, hey, those models contain the data over which they were trained, and it's really trivial to pull it out. The technical term for that is called model inversion and model extraction, which means there's a ton of vulnerability relating to models. So you have to apply this kind of model-centric security approach to using models called evaluation inference that have been trained over that sensitive data. The place that privacy-enhancing technologies come in and uniquely protect that is that what they enable you to do is take a model that's been trained over sensitive data. You can now encrypt that model, and now you can go run that model over other types of data across boundaries, across silos, et cetera, without ever decrypting the model at any point during processing. If you don't decrypt the model, you never get to see the model. If you can't see the model, you never have an opportunity to pull any of that sensitive data out of the model over which it was trained. That sensitive data encoded in the model is protected at all times while it's being run and processed in the data environment. So the net effect of that is the security enables now the organization to be able to use those sensitive models in ways and places that they could have never done before in order to extract the insights that should be uniquely available to them through AI and machine learning. So that prevention from a technical perspective of things like model inversion, model extraction, which is pulling that data out, is one reason why. We'll get to the second reason why in just a second, but that's one reason why that you see, for example, the White House AI executive order for safe, trustworthy, responsible AI mandating the use of privacy enhancing technologies for these AI ML workflows, because they inherently protect the model and the data encoded in that model, which is going to have a whole lot of sensitivities to it. And then that's why you see it echoed globally in all those other guidelines that I mentioned as being either mandated or indicated as best practice for protecting the models themselves and protecting the data contained in the models. So huge uplift there.
We can I'll just randomly pull out a federal application, waste, fraud, and abuse. And if someone's trying to determine if a company in Florida is abusing the tax system, I mean, think how many different types of sensitive areas they have to delve into. And I guess one of the risks in using artificial intelligence is just the fact of doing that opens up vulnerabilities, and this PET technology can allow them to find the waste, fraud, and abuse without compromising what they're looking into, isn't it?
Absolutely. You could apply it in that way. If you trained that model to detect fraud, waste, and abuse over sensitive information, then sending that model out to run, which is where you're going to do that detection, is the same thing as sending all that sensitive information that you've trained the model out to that location as well. Huge problem. That's where it breaks down from the perspective of needing to protect the models themselves. Now, they contain the data. A lot of times we see, just in parallel in the commercial world, the models are considered intellectual property for the organization. So sometimes the models in and of themselves, being IP, need to be protected regardless of the training data that they were trained over. But primarily we see as a driver in the commercial space, and of course in the federal space, that you need to protect the model, not because it's intellectual property necessarily, but because it reveals the underlying training data, which is a big problem. So the second vulnerability that you see with models in a model-centric way is when they're being trained or used, they can be spoofed. The data can be poisoned. So an adversary can observe the behavior of the model as it's either being trained over data or run over data, evaluation, inference, to make those decisions. And by observing the behavior of the model itself and its behavior, as those things are happening, it can now understand how to intelligently dork with the underlying data in order to get the model to make the decisions that are advantageous to them instead of the ones that they should be making, or the model to learn to make the decisions that are advantageous to them instead of the ones they should be making. That's model spoofing, that's data poisoning. And if you have that going on, the end result of that is you don't have any integrity in your machine learning workflow. You can't trust that the model is learning to make the decisions that it should be making, and you can't trust that the model's making the decisions that it should be making. So you lose all of that integrity. Where pets come into play is they can encrypt that model. So I can encrypt a model with privacy enhancing technologies and send it out, again, to be run, like we talked about before, or to be trained or to be learned in that environment. And it's never decrypted at any point during that training or that evaluation inference process. So the model's never decrypted. And then the outputs of the model, the decisions it's making, are also encrypted at all times in that environment. That's the kind of power of pets. So as an adversary, if I don't get to see the model and I don't get to see the decisions the model's making in that environment, then I can no longer intelligently dork with that underlying data to get the model to make the decisions that I want it to make instead of the ones they should be making. So it cuts off on these really key areas of adversarial machine learning relating to intelligent model spoofing and data poisoning. And by doing that, not only do you protect the models, the data contained, all of that good stuff. But now you enable integrity in your machine learning workflow process. So I can trust that the model is making the decisions that it should be making. The model is learning to make the decisions that it should be making, which you can see is going to be key and critical for any kind of operational use for machine learning in the federal ecosystem, as well as in the commercial ecosystem. So really, no matter what vertical you look at, integrity in your machine learning workflows is really, really important. And that's obtained. Privacy enhancing technologies have a huge, huge role to play there. And that's the second kind of key reason you see it being mandated or indicated as best practice as a family of technologies for the ability for that model-centric security.
If we go back in time machine 7 years, and I would suggest to talk about model spoofing, it's changed so much. And it's just, in order to keep on top of the things, you got to listen to interviews like this, you got to read articles, and, it's a hot summer day, 6 months from now, snow on the ground, people want to learn more. I think you've maybe written an article for HelpNet Security. Is that right?
Yes. So there's an article for HelpNet Security that kind of unpacks this, and also a video that goes along with that. So if people are interested in learning more, they can certainly go check those out.
Well, a video they're going to love. What I will do is I'll put a link in the show notes to this article. It's called Harnessing the Power of Privacy Enhancing Technologies for Safer AI Adoption. So if you're out walking your dog and you're listening to this podcast and kind of piques your interest, you can go back and read the article and watch the video and then get a better understanding of this whole PET technology. But the question is, then what? So you go back to your agency and you look around and go, well, where do we stack up? I mean, what are the best practices to assure that my agency is using, AI in a safe and secure way? So how do you look in the mirror in this one? How do you know about your agency?
Well, you got to go end to end, all the way through. I think the best framework that I've seen to date that addresses it holistically is Gartner's AI TRISM framework, trust, risk, security, management framework. And a key part of that framework is privacy enhancing technologies for that model-centric security viewpoint that I mentioned before. And those two key pillars that they tie off on, but they also present a very holistic look at that AI workflow. How do you secure it and make sure that it's safe, securely responsible, et cetera, end to end, et cetera. So I would say that that's a really great way to take a look at it, all the way from an application security perspective, access control, audit verification standpoint, and then down to a data-centric, model-centric security standpoint as well.
I was doing an interview on quantum here, middle of the summer, and when you said the word encryption, okay, I acted like a pet, and my ears went up. And I said, "Oh, encryption." So let's talk about the 500-pound elephant in the room. I mean, so what about quantum? Is this going to break everything, or break your rice bowl, as they say?
Good news now. So privacy enhancing technologies. When I say models get encrypted, there are a couple of ways to do that in the privacy enhancing technology family. One of the key ways is through a capability called homomorphic encryption, which is a way to perform these kind of computations in the encrypted domain as if they're in the unencrypted world. So ciphertext space as if it's plain text space, or I like to say kind of the real world, whereas humans could consume it. So from a homomorphic encryption perspective, NIST has, of course, come out and certified that the underlying encryption kind of primitives that back homomorphic encryption are in fact quantum resistant. So the good news for people who are adopting privacy enhancing technologies is there are choices to adopt certain technologies in that family that are in fact already known to be quantum resistant. So you can make sure that you're protecting your models and providing that model-centric security for secure AI with capabilities that are known to be quantum resistant, which is what you want to do because you don't want to have to go redo it.
Yeah, because I see trends and I see more and more interest, and I think this quantum interest has been around for the last few years, but suddenly it seems to be catching on, more and more people talking about it. Maybe the technology is allowing to advance. And I think this is important when we talk about PET, to let people know that, we thought about that, John, and the listeners, oh, so they really thought about that. Oh, that's good. So, when you hear about artificial intelligence, you learn about large language models, LLMs. And so how can something like PET help us work and develop LLMs in the future?
Yeah, large language models are very interesting in that they've been around for a while, but they've risen in this kind of awareness from a global perspective that we haven't seen before. Again, kind of thank you to ChatGPT. The reason LLMs are very interesting in a number of use cases, in particular in the federal space, is for their ability to help with use cases around semantic types of search. So semantic search would be manifested in you or I asking questions to each other. So I can ask you a question, the human brain can process it, you can, give me an answer in a very contextualized kind of a way, versus more syntactical kinds of searching where you have specific keywords that you want to go look for and things like that. So semantic search is powerful in the way, in that it models the way a human would interact with another human. That's great. That can give us, a lot of efficiencies, et cetera. And so I think we'll continue to see this utility increase and kind of blossom and mature over time. One of the things, though, of course, we're seeing in practice is, people are starting with low barrier to entry types of applications for LLM with, automatic chat functions with customer service or kind of analyst prioritization of things they may want to look at, et cetera. And that's all great. And it's a great place to start, crawl, walk, run, of course. However, to use LLMs in practice, oftentimes, you need to be able to cite a source. You need to be able to determine whether the answers that you're getting back make sense. And if they do make sense, at what level do they make sense so that you can make sure that you select the best one? And then how do you cite the source that would have come from, especially if you're going to use it in operational decisional kinds of a context? So one of the rubber meets the road aspects of deploying LLMs that we see growing, and I think this is a good thing, is variants of something called retrieval augmented generation, which is a fancy kind of term for I'm going to ask the LLM a question, and when I get back an answer, it comes with a source that it cites, with a passage of content from which it pulled that answer for me. So now as a human, I can see, does that answer make any sense? Is it wacko or, hallucination in the LLM kind of parlance? Or if it is an intelligent answer, how intelligent is that answer? And then if I'm going to use that in a kind of recommendation that I'm going to make for a decision, I can now pull a source document and attach it to that answer. Critically important. So you'll see kind of this prominence of RAG or retrieval augmented generation, all kinds of variants that are coming out around that gain, I think, traction over time here in the federal space. But pets can play a huge part in even the adoption of retrieval augmented generation, because under the hood, you're still pulling this kind of content, and the mechanisms that are working there are over data. And you still have the same problem of your data being distributed across all kinds of boundaries and silos within the organization, outside of the organization, could be different kinds of classification domains into third parties, et cetera, where those silos of data have to be respected at all points. And so then the question is, if I'm going to ask this LLM a sensitive question in one kind of domain, then if I send that question in essence, there's a little bit more technical depth here, but we'll keep it high level for now. But if I'm going to send that semantic question, the sensitive content of that question out to maybe a lower classification domain or a third party, in order to get a good answer from it, from an LLM-powered type of solution, that's a huge problem. You can't do that. So that's where privacy-enhancing technologies can come in, and they can provide the ability to be able to ask that semantic question of an LLM in an encrypted way, and then get back the source backing documents and the content. So it enables operationalization of LLM capability, or this kind of RAG workflow in the real world, where data is often distributed across boundaries and silos, and it needs to stay there, and those boundaries and silos need to be respected, and you don't need to expose sensitive content from one silo inside or across a boundary of another silo of information.
I'm thinking about NIH. I don't know how many silos you must have there, and they have sensitive medical information. However, in order to unlock intelligence from that data, it has to be handled responsibly. And maybe the combination of RAG and PET can allow the people to actually pull information from all that. And they're getting so much every day. I mean, we haven't even talked about the quality of the data. I mean, we're about the end of the interview here, and I'm going to bring up a 5-hour. What about compliance? I mean, it's a whole topic here involving with getting a hallucination, worrying about RAG, and then PET, PET, and so it's a topic that's just exploded in the last few years. And I want to continue this conversation, and maybe the next time we can go into just data itself and how to use data to create a valid LLM and then make sure that model can work with that one.
Yeah, and privacy enhancing technologies is, you're kind of cutting to the core of it. As a family of technologies, they serve to protect the usage of data when data is being used or processed. And where they really come into play and shine is enabling data to be used securely and privately, where it is and as it is across a myriad of boundaries and silos. And there are really only two macro ways to use data, which is where you're going to extract the insights from the data that's otherwise sitting there at rest in the file system, in the database, et cetera, that should yield value for the organization. So the first is search. You're going to run a search over it, right? Search kind of powers the world, see Google and other things. Or the second, you're going to run an analytic over it. Analytics also include AI or machine learning. So we started with one application of privacy enhancing technologies, which is AI, which is secure AI, secure machine learning, et cetera. But really they applied to securely and privately using data across any kind of boundary and any kind of silo. But as you've heard, very, very, very powerful implications to provide unique model-centric security, which are key in a number of ways for organizations really adopting this kind of AI ML technology. And of course, one aspect of that is LLMs, and another even further aspect of that is retrieval augmented generation. So it depends how far down the rabbit hole of using data securely across boundaries and silos you want to go, but privacy enhancing technologies still apply.
Yeah, major levels. Well, let's continue this conversation. Maybe we'll look at compliance and some of the innovations, because I'm just, with this type of discussion, in the next 3 or 4 months, something new could come up, and then this hallucination, the response, and then this and response, and so it's a whack-a-mole game here with the federal government security. And it's, as you said at the beginning, it's the same thing in commercial organizations. They're encountering very similar problems. They have to respond somehow, don't they?
This is a global problem. This is not only a federal problem. It's not only a commercial problem. It's appearing in every single vertical. And why is that the case? Because these boundaries and silos of data exist everywhere, no matter where you are, and data is sensitive for a number of reasons, no matter where you go. Yes, in healthcare, it may be patient records, patient information, et cetera. In financial services, it may be personal data, banking information, et cetera. But in the federal government, classified selectors, sources, methods, TTPs, et cetera. Sensitive data exists everywhere. Boundaries and silos exist everywhere. They just take different forms depending on the vertical and the use case. And that will be true, of course, with AI and ML. And anytime you see this kind of rapid adoption, you're also going to see rapid innovation, which is really exciting for us working in that space. But you're also going to see very rapid escalation of challenges relating to implementing it and deploying it in a secure, responsible way, which is also an exciting space to be in.
Yeah, innovation, two-edged sword, malicious actors and the federal government, and they can both benefit and get attacked by it too. Well, good. Unfortunately, here we're running out of time. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Dr. Ellison Anne Williams, CEO of Enveil, Enveil. Thanks, Ellison.
Thank you, John. Appreciate it.
Thanks for listening to the Federal Tech Podcast. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcasts.